Hello student, now I'm going to start lecture 5, right? So in lecture 5 students, what is the point which I'll discuss in lecture 5 students. In the previous lecture I discussed pressure distribution due to static fluid, right? So what is the measure for that lecture? Pressures due to liquid, right, on the base of container, that is what we got rho GH. And students, one more thing I said in that lecture, students, pressure is independent on area cross section. That is a very important formula. Pressure basically depends on what you can say, if you remember the formula rho GH. So what you can say is, this is what basically directly proportional to G forever constants density of liquid and height fit in the container, right? So in today's class students will discuss that is literally super important. Students force on what, my dear? Side wall of a vessel, right, my dear? Okay. So here students, I can say what's the point, students. First I'll just draw the diagram. So you can say this is what, my dear? It's a, I'm showing cuboid, right, my dear? So this is the cuboid. Okay. So students, here I can say a few basic points. We can say this is length, this is what, my dear? It's breadth, and this is what you can say, this is the height, right? So here students, this is the container. Entire container you can take that is filled with a liquid till top, right, completely. Okay. So what's the things we have to find? Force on a side wall of container. Students, you can take example. Let us suppose this is the container, right? This is the container. So this container is what, filled with a liquid, right, my dear? So what is the you can say water or liquid inside the container acting, what this is what, always normal to surfaces, right? So this is direction of what you can say beta G, normal force on a container. So we have to find this value basically. What beta? We have to find this value basically, right? So students, for this condition you can't write directly because force on the side wall of the vessels cannot be directly determined as the different depths. What is, students? As the different depths, right? Pressure are different because if we are changing the height, so what you can say, pressure will be also change. So we can't write force formula directly, pressure per unit area, or you can say force is what, pressure into area, not possible at all. So what we can do, students, if you remember class concept, if there is anywhere variation in a linear way, then beta G, what you can say for this condition, students, if you remember the things, we have to move x and take element dx. We have to move x for linear variation. I hope all of you remember. For linear variation, what you can say, my dear, you have to move x or it's a particular direction. So I'm calling students, I'm moving by, and students, I'll take element of dy. It's a 3D element, so just try to understand the things. So we have to move by and take element dy. So what is, student? This is the, you can say, element which is what, dy. So due to this element, first we have to determine what is the direction of force, because what we wish to find, force basically, right? If we wish to find force, as I said, force always normal to the surface of a container. So we can tell, my dear, this is what direction of force. So we can tell the student this is what direction of force, which is you can say df, which is you can say df. So what is the force? Students, you know force we can write pressure into area, right? So students, I am going to write this is magnitude of df. So students, here I'll use force is equals to pressure into area formula, right? So what is the pressure here? What pressures due to liquid, my dear? Here what pressures due to liquid? Just now I said in previous lecture number 4, pressures due to liquid, what? Rho gh, right? Student, what is the height over here? This is y. So you can say pressures due to liquid, my dear, rho g by. This is what pressures due to liquid, rho g by. So here students, you can write rho g by what? It's a rectangular strip, right? So what's a strip? You can say length into breadth. So what's the length, student, and what's the breadth? This is what, you know, this is b. So what you can say there, b into dy. So this is area of a strip, because pressure is what? Force into area. But this is expression only for one element. But we wish to find what is the force on a side wall due to, because now we have taken only one strip, right? But you can, so there are many small strip. So for that conditions, if you want to entire force, so what we have to use? Mathematical tool. What is, student? We have to use mathematical tool. And what's the name of that tool? Integration. Because you know, if you want to add many small pieces, then what you can apply? Concept of integration, my dear. So here I'm going to apply what, student? This is what? Integration. So we can say this is what? df is equals to what, my dear? Rho g by b into dy. Okay, limit what you can apply? Here simple, student. This is 0 to f, and here what beta g? You can say 0. What is the height of the cube? White. This is what? H. You can say h only, my dear. So this is what? df becomes f only. F minus 0. I'm expecting all of you know f only. Now student, this is rho g b. Integration, students, I'm doing here one time for your sake of convenience. You know, if you remember formula of x to the power n into dx, what you can say? X to the power n plus 1 upon n plus 1. That's all, right, my dear? Okay, so same thing you can apply over here. So you will get by a square by 2. It's indefinite, but here is what, student? It's a definite. So you can say directly by dy by a square by 2, by a square by 2, my dear, and limit you can apply 0 to h, right? As usual, students, just we have to replace limit from variable. Limit, first we have to apply upper limit minus lower limit. So f is equals to rho g b. This is h square minus 0 by 2. So what is the force on side wall of container? F is equals to rho g b h square by 2. Students, not a single time, multiple time they already asked only formula, force on a side wall of a vessel. So keep in your mind, it's a highly important. Rho gb h square by 2. Students, take a snapshot. I want you to turn the page. Okay, I hope you have already taken. Now students, have a look next. So next beta, I wanted to discuss, this is what we found, because there are 3 questions. These all are interlinked to each other. Students, here I can say pressure, or you can write in better way, students, it's the average pressure on side wall. Average pressure on what, students? You can say side wall. Okay, fine. Students, for this condition, average pressure. So pressure average, either student you can use this tool, or you can also say pressure average. It's nothing but what you can say, force per unit area. Force, student, force just now we calculated, F is equals to how much? Rho G B H square by 2. Now just finish now. Formula, I can say this formula derivation. So now students, I'll use this thing. So you can say rho, and what's the area? This is base into height. So now students, you can say rho G B H square by B into H into 2. You can see, student, this BH and BH cancel each other. So what you will get? Pressure average, which is equals to what, my dear? Pressure average is equals to rho G H by 2. So I'm giving you one short trick, but there is not any such proof and all. For memory, for further, you can also use pressure is what? Rho G H C1. There is no any mathematical formula, just I'm giving you idea to remember how pressure average on the side wall of the container. So what you can say, rho G H C1, and HCM is what? H by 2. So by this way you can remember the formula also. So what is it? This is the pressure on side wall of container. So now I got the result. So there is one more questions. That is what I can say, questions number 3. These three are interlinked to each other. These three students' questions interlinked to each other. Okay. So students, I can say for this condition, what is the thing, students? We wish to find torque. So this is torque. Torque on the students side wall. Torque on the side wall due to what, student? Tell. Fluid pressure. Due to what, students? Fluid pressure. Okay, fine. Students, for this condition, what's the things? Here again I'm telling you, you can't write directly torque formula. You can't apply directly torque formula, or you can write force. Torque is what, students? As we know, everyone. Torque, what I can say, this is R cross F. I'll use this formula. I shall use this formula, but condition is that because these are interrelated questions. So instead of write torque, we have to write expression for small element, right? So what is the expression of a small element for DF? This is, I'll use this result from here only, right? So students, here, because we wish to find torque, due to this, I shall write d tau for a small element, right? Because again, torque not possible to write directly RF sin theta, right? Students, here you can say torque is what, students? You can say force is what? dF into perpendicular distance. What's the distance here? This is what? By. So this is what? H minus by, my dear. This is, you can say, H minus by, right? So this is what you can say expression of torque. Now dF already we found in previous questions, so you can use directly dF from here. What is dF? Rho G by B d by. Students, here you can write d tau rho G B by d by into H minus by. Students, open the bracket. So this is d tau, my dear, rho g b h into by into dy. Students, this is expression for a small element, single element. We wish to find entire. So what is going to, we have to apply tools of mathematics. That is what you can say, integration. So student, here what we can apply the limit, because we took element in vertical direction. So limit as usual, my dear, you can say 0 to h, right? So students, here you can write limit as usual 0 to h only. Okay, now students, you can say minus rho, this is what beta, rho g b into beta g, what you can say, rho gb into what you can say, this is by square into d by. Now students, limit apply both of the side, 0 to h, my dear, here also 0 to h. So d tau, student, this is remains tau only, right? This is rho g b h, and this is what, by dy, what you can say, by square by 2, limit student 0 to h, minus what, my dear, rho g b, this is by q by 3, limit 0 to h. Now students, further you can calculate rho g b h square by 2 minus rho g b, this is what, my dear, you can say this is what, hq by 3. Now students, this is the condition, h is missing over here, h also remains same, so torque is equals to rho gb, you can take common, better for you. This is what, hq by 2 minus hq by 3, my dear. 3 to the 6, you can take LCM, my dear. Torque is equals to rho gb upon 6, and this is what, you can say 3 hq minus 2 hq. So this is what, 3 minus 2, 1. So you can say beta rho g b hq by 6. So student, this is the, I can say, answer which is supposed to keep in your mind, because they multiple time ask this formula directly. Student, directly they ask force, average pressure and torque formula, rho g b hq by 6. So this is answer. So take snapshot. I'll see you in the next class, next lecture.